Welcome to BamfordRose and another question of the week. This week's question of the week is there a reduced mobility option for your Aston Martin? So if I was to have my time in engineering again, I'd really like to get into biomechanics. I really love new technology, materials, technology, electronics, and the application of that to increase mobility is something that really interests me. So it's really great to review this V12VS paddle shift option with a reduced mobility enhancement kit on it. So on the steering wheel, we have this ring which you push, and this acts as your throttle, and here we have a hand controlled brake lever. So if you have reduced mobility, because the V12VS is obviously paddle shift, then you've got everything at hand control. You've got your gears on the paddles, throttle on the push ring, and brake lever on this hand control here. So this system is from Guidosimplex, and link to the website is here. And as far as I can gather, you buy the basics of the kit and then you need to find an installer to fit it and commission it for you. Now, that's not the only enhancement that this V12VS has got. It's also got BamfordRose manifolds and catalysts fitted. So we've got 565 bhp, and with the manifolds and cats ECU remap, then we're certainly well over 600 bhp. So let's take it for a spin. Check out this reduced mobility kit at over 600 bhp. And what could go wrong? Hand control throttle, hand control brake. So to start the V12VS, because it's paddle shift, obviously you need your foot on the brake, but on the reduced mobility option we have to push the lever for the brake control, and then we can start as normal. Now underneath the dashboard is a toggle switch which allows it to switch between the hand control throttle on the steering wheel and conventional foot control. That's the really clever thing about this system. You can switch between the two and drive the car conventionally or drive it in reduced mobility mode. Now the hand controlled brake lever operates not on the pedal of the brake, it operates on the arm, meaning that if you do switch it into conventional mode, you can operate the throttle pedal and the brake pedal as completely normal. Then when you toggle the switch to control the accelerator by the hand control, that disables the conventional throttle pedal, and you could still always use the brake conventionally, but obviously in reduced mobility mode you're going to be using the hand control lever. So we started this in conventional mode, and I'm now revving the engine up on the throttle. You can't toggle between modes with the ignition on. You have to turn off, reset the mode and turn back on again. So if I operate the hand control throttle, it doesn't work. So turn the engine off, flick the switch to control it into steering wheel control throttle, hand control brake lever, start the engine, and now this push type device controls throttle. Now there's a little stepper motor here that I can see. So the throttle pedal outputs 0 to 5 volts and works out throttle blade angle from how much the pedal has been pressed. So this stepper motor has obviously been designed to replicate that 0 to 5 volt output, and I can just tell by blipping the throttle there and then looking at its maximum range, it's very aggressive on that initial press, and I'm sure that with experience you'd overcome this, but for me I'd want the first sort of 10 or 15% of travel on this push ring to be quite damped, quite lazy, because I just use that for pulling away. So I don't want a lot of throttle blade angle being set for quite a small press of this ring. And then after that dead period, it can go into wide open throttle. So that's going to be interesting to figure out how that behaves on the road. And then as I'm pressing that to pull away, I'm going to have to sort of lean on that brake lever. Now I can tell just by starting the car, manoeuvring it in the car park, that a very small amount of pressure by hand is needed just to get a small amount of brake force. It's very easy to overpress this and go on the brakes. So it's going to be interesting to feel what this is like out on the road. So let's set sail in our reduced mobility 600 plus bhp V12 Vantage S. So push down on the hand control brake lever, select a gear, and I'm going to come off, a little bit of throttle, handbrake off. Yeah, as I initially thought, that first little bit of travel on the hand-controlled throttle is very sensitive. If there was the ability to calibrate that, to dampen that off, then pull-aways would be a lot smoother. As soon as you've pulled away though, you could change up to second and third, and because the V12 engine has got so much torque, then you could avoid the jerkiness by having it in a higher gear, and that initial bit of throttle opening wouldn't return the jerkiness. Right, I'm just going to practice a bit of a brake, and yeah, with a small amount of lever pressure, you get quite a lot of brake force. I'm positive that with experience you'll get to learn the pressure needed on the hand control lever to give you the brake reduction that you need, but to start with, that's quite a learning curve. Right, so now we've got to grips with the system. Let's take it around the BamfordRose loop. Yeah, I think that's safe to say that the hand control is getting full throttle. Also safe to say that all of those BamfordRose 600 plus bhp horsepowers are actually there. It's also quite interesting, the mechanics of the driving controls are actually quite appealing. To, on your thumbs, delicately push down on throttle, and then on the fingers go up or down a gear is really precise. And if you've got your hands in a performance car driving style, instead of doing the old style shuffle, then you can actually corner and with precision control throttle and gears, and it's really delicate. And also the brake, I've got to calibrate myself to getting used to the brake force for the amount of lever arm force that I apply, but I'm sure that's just experience. But it's a mechanical link to the pedal. I'm just wondering that on this hand control, if there was some electronics where you could have almost like a trigger control, then you could be as delicate on the brake as what you are with the gears and the throttle control. Obviously, a neat little electronic trigger solution like that could go wrong and you're left with no brakes. But if you were to sort of flip some sort of toggle switch on the little trigger that reverted the lever back to manual control, then you'd have a mechanical backup to electronic braking aid. And And with something like that done, then you'd have brake control as precise and delicate as the throttle and gear control. Now, I just had a really long car journey yesterday and my legs are really cramped up. So to jump into this today with my legs aching and experience really delicate and nice hand controls for throttle and gears on the steering wheel with a nice brake lever being hand controlled is actually quite nice. It's very comfortable. Now, driving cars, riding motorbikes, and I do fly aeroplanes, I'm used to lots of different hand controls in lots of different applications, and it's very familiar to me to very quickly get used to this system, and I actually quite like it. So reduced mobility or not, it's actually quite a good option. I just driving that bit of the BamfordRose spiritedly to the limit of the national speed limit. It's really intuitive to pull the paddle for a gear, go through the rev range, then when you need to scrub some speed off for a corner, just roll your hand over off the steering wheel, hit the brake pedal, and it really flows. It's really enjoyable. So now we'll just go into the workshop, stick a laptop on the car, and we'll data log what throttle blade angle is versus the press, the range of this hand controlled throttle. I'm sure it can be calibrated to behave much better than what it is, and that would put the icing on the cake to this package. Right, so we've got the engine ticking over. It's in hand throttle control mode. At the bottom two parameters there you can see throttle angle, so that's the actual blade angle, and then you can see what would have been a pedal position. So if we just give it a little press, that's just the least amount on the hand control that I can press, and instantly we're sort of going up to 4 degrees blade angle, and just a little bit more and the blading angle increases to about 10. Now at that very low engine speed you're going to have maximum airflow, so basically full throttle would give you no more at something like 15 or 20 degrees. So with just a very small press, it's basically getting up to the airflow that it would be approaching full throttle. So that explains why it's quite snatchy on that initial take up. So we press it halfway, then it's certainly getting up to what would be the equivalent of full throttle at half input on the hand control. So that's why this could really do with being calibrated to give a more drivable, easier throttle progression curve in relation to the amount that you press the hand control. We'll just check that it is actually getting full throttle. So momentarily we're going to want to see there that the accelerator pedal position goes to 100%, and we see something like 90 degrees on the actual throttle angle, which it does. So it's getting full throttle fine. So yeah, this is behaving really well, apart from just to put the icing on that cake, just needs that bit of throttle progression calibration. So there you have it, the Guidosimplex reduced mobility option for your Aston Martin. Give us your comments. Have you tried any systems like this on an Aston or another car? There aren't many official installers of this product in the UK, and because I'm so interested in this sort of solution, then it's something that I'd like to get into, and perhaps we can refine the controls to improve the package as it is at the moment. Hope you like that question of the week. We'll see you on the next one.